Hi everyone. In this week's lecture, I learned about building a system in software engineering and how complexity increases as the system becomes larger. One of the main concepts that we focused on was depth and breadth of software complexity, actually in software complexity. So first, depth refers to how big the system is. This includes things like number of users, number of datas, and how many components or modules are involved. For example, if system has many features and supports a large number of users, its breadth is high. As breadth increases, the system becomes harder to manage because there's a lot of things to manage at the same time. On the other hand, depth refers to how different parts of system are connected. It focuses on relationship between components, such as how data is shared or how control flows from one function to another. A system becomes deeper when there are more dependencies and interaction between components. For example, if one function depends on another and that function depends on another, it creates a multiple layer, which increases the depth. It makes the system more complex. So I learned that both depth and breadth increases the complexity, but in different ways. Breadth makes the system larger and harder to manage, while depth makes it harder to understand how everything is connected. If both are high, the system becomes very complex and difficult to develop and maintain at the same time. Another important topic from the lecture was the difference between writing a program and developing a system. So, writing a program is usually something done by one person or a small group of people, and it focuses mainly on coding as a specific task. Um, it is relatively simple in compared to building a system. However, developing a system is very complex. It involves many components and usually requires a team of developers. It also includes multiple stages such as requirement gathering, designing, coding, testing, and maintenance. So it's not just about coding, it's about managing the whole process. Um, the lecture also highlighted that system development involves both technical and non-technical challenges. Technical challenges include things like design, tools, and testing. Non-technical things, challenges include communication, coordination, and managing people to work as a team. As the number of increases, as the number of members in the team increases, communication becomes more difficult and there are more chances of misunderstanding. One thing I found interesting is how the number of communication paths increase when more people are involved in the project. This shows why coordination is very important in software engineering. I also learned different ways to handle complexity. Some of the main approaches include breaking the system into smaller parts, which is called decomposition, and using modular design so that each part can be developed separately. Another approach is using proper tools, technologies, and processes to manage the system more effectively. Um, in terms of my software engineering project, I think this knowledge is very useful. Since we are working in a group, we need to divide the system into smaller modules so that each member can focus on one specific task. And I think doing that increases the efficiency and makes the end result um, more proper as well. Um, Also, we need to communicate clearly with each other and coordinate our tasks properly. If we don't do that, the system can be confusing and difficult to manage. Using a structured process like planning and regular updates will help us stay organized. So, overall, this week helped me understand why software engineering is important when building large systems. It's not just about writing code, but also about managing complexity, working in teams, and following proper processes. Thank you.